R programming, hypothesis testing, comparing more than two independent groups. If you want to compare more than two independent groups, you can apply one-way analysis of variance, or also known as one-factor ANOVA. One-factor ANOVA is an extension of independent two-sample t-test for comparing mean in a situation where there are more than two groups. In one-way ANOVA, the data is organized into several groups based on one single grouping variable, also called factor variable. So in R, we use the function of AOV and then the function of summary.AOV to summarize the analysis of variance model. So for example, let's say we have the iris data. Okay, refer to the iris data, conduct the analysis of variance to compare the mean difference of sepal length among species. So if we refer to the iris data, so based on the species, there are three types of colors. So there are three types of species: Virginica, versicolors, and also setosa. So we want to determine is there any difference or not in a sepal length. So we can use analysis of variance. So to use the analysis, to use the ANOVA, so you must test the data normally distributed or not. If the data is normally distributed, then you can use the ANOVA. Let's assign the object here iris ANOVA, and then use the function of AOV, and then let's say what you want to compare here is the sepal length. So put here sepal length, and then sepal length according to the tilde, and then followed by the species, and then you must provide the data. Okay, so the data is come from iris. So I just copy paste this one, click copy, and then paste. So if I run the iris ANOVA, okay, if I run the iris ANOVA, so I will get the analysis of variance for the sepal length according to the species, but the analysis is not complete. Okay, so therefore to get the full result, okay, you can type summary of the iris ANOVA, run. Okay, so you will see there is a p-value here. So based on the p-value here, you can make a decision whether to reject or do not reject the null hypothesis. So in this case, okay, the p-value is 0.000, so e negative 16, meaning that there are 16 zeros before the other numbers, 0.000 and then followed by 2 something. So therefore the value of p, or the probability value, is very small, and then we reject the null hypothesis and conclude that there is a difference in a sepal length among the species. Okay, and then if there is a difference, so the next step is to determine which group is different from each other. So we can use the Tukey HSD for multiple comparison. Okay, so we just type Tukey HSD. Okay, iris ANOVA. Okay, you can see that for versicolor and setosa, there is a significant difference based on the p-value here. P-value equal to 0. Virginica and setosa, also there is a significant difference. Virginica and versicolor, also there is a significant difference. Thank you for watching.